in a better way. So this is 74. Sorry, this is 70. Let's say this is 74. Let's say this is 78. 78. Okay. Let's say this is 78. Okay. S3 is, let's say, 80. Okay. Now let's say again 76. Now if you draw this train, okay, x1, x2, so this is x1. Sorry for this. This is 74. Now this is x2, which is 78. This is x3 bar. Okay. There is a bell-shaped curve always be there. And let's say there is a one more, which is, let's say, 70. X4 bar and X5 bar. Okay. So this is what the concept shared by the central limit theorem. Okay. This was the concept shared by the central limit theorem. Sample size. N stands for sample size, the one. Sample size. Okay. Here, if you observe, the sample size is here 150, above 30. Here also it's like 100, above 30. Here also it's like 120, above 30. Let's say here assume 100, above 30. So whenever you choose a sample of size above 30, which is known as, which can be labeled as a large sample, then you can say that those small samples, okay, those small samples, okay, sized above 30 can also follow normal distribution if the population is following normal distribution. Okay. In one sentence, if I conclude, this is known as a distribution of sample means. Abhi tak you have seen the distribution of observations. Now, koi ek population ke liye, if the population is too large, follows normal distribution. If you draw some small samples with more than 30 observations, with more than 30 respondents, then those samples can also follow normal distribution. They can also exhibit normal curve. And if they don't, then their means, okay, their means, if you plot their means together on a piece of graph, so har ek sample ki mean together shows the bell-shaped curve. Har ek sample ki means together, they can show the bell-shaped curve. This is known as a distribution of sample means. Let me repeat again. If population follows normal distribution, and if you repetitively draw these samples having more than 30 respondents, then if you calculate their means, if you gather the mean at one place in one graph paper, okay, their means will follow the normal distribution. They will exhibit the normal curve. Okay, yes or no? Have you understood the central limit theorem? Only statement is required to understand. Yes, yes, Kamlesh. Yes. Have you understood this? Yes or no? Have you understood this? Yes or no? How many of you have understood this? Yes, many of you are saying yes. Now let's follow some basic examples. Now here you are going to find out, if you remember up to last chapters, numericals, or let's say if you remember the examples that we used to solve in the last chapter, which is based on the distributions of observations, distribution of observations, right? Discrete observation or a continuous observation. But now we are going to deal with the means. Okay, now we are going to deal with the mean, distribution of the means. So here two possibilities can be there. Either the population, population size is known to us, or no, or it is not known to us. Okay, so let's discuss some examples like that way. I'll at least tell you that what is the difference. So this is the first problem that I have picked up. Suppose that during any hour in large departmental store, the average number of shoppers are 448. Total number of customers or the shoppers are not known or not given to us. So it's not known for us. So population size is not known for us. Do you agree with me? Yes or no? Okay, so for us it's not known. Okay, so they must have at least gathered the information. They must have at least, the experimenter must have a population size and calculated the mean and the standard deviation based on the population data. Now asking us that from that population, if we repetitively draw the sample, okay, or let's say if we conduct the if we repetitively draw the sample, what are the chances that, what is the probability that the random sample of 49 different shops, shopping hours, okay, 49 different shopping hours will yield the sample mean between 441 to 446. 441 to 446. Here the small n is 49 because we have to consider the 49 different shopping hours. Okay, they have given that the average number of shoppers is 448, okay, in a typical hour. Okay, now we need to find out the probability. We can express this probability as this. This is a big population, okay, and in a typical hour, okay, in a typical hour, 448 customers are on an average. On an average, 448 customers are there. Okay, standard deviation could be there. I mean, okay, if you choose a time slot of 1 to 2 and 2 to 3 and 4 to 5, of course you'll find a variation of 21 people. Okay, now asking us to gather sample, okay, of 49 different shopping hours. Okay, 49 different shopping hours. We need to find out that what is the probability that here this time the sample mean would be between 441 to 446. We need to calculate the Z value then, because if you look at the X bar up to here, we used to plot up to here, we used to at least draw the normal curve for observation, but this is a normal curve of X bar. This is a population average. Population average is 448. Okay, now we are looking for the sample average. Okay, range. This is a range of the lowest low value of the sample, 441. This is the biggest value could be imagined of X bar, 446. We need to find this probability of this region. Okay, so this can be mathematically, can be written as this, and the formula is very much related to, so this is nothing but the probability of X bar is less than 441, okay, plus X bar is less than, X bar is greater than 441. This is the first possibility, and this is the second possibility. X bar is less than 446. Okay. Now, as we remember last time, if you remember the last times, practice of reading the z values. Let me just at least go with the type A chart that I have shared with you, Z table that I've shared with you, or it's known as a cumulative probability table. तो Z का जो cumulative table होता है उस हिसाब से this can be determined by X bar. There's no problem in it. But what we need to do is there's a repetition. So we can do one thing. If we need this area, we can find out X bar less than 446 minus probability that X is less than X bar, matlab sample mean is less than 441. This way we can at least get this region. Okay, 448 minus 441 will give you this. Okay, now what is the formula here? The formula is this. What is this? This is X bar minus mu sigma by root n. Okay, why we have considered this root n? Because population size is not known to us. It's not given to us. And this mean is population mean, and this standard deviation is also population standard deviation. And we are discussing the probability of sample mean would be between some two values. Definitely we need to use the and we have been given the sample size, right? So why can't we use it? So that's why we set the sample size in the denominator part. Okay, so Z value is less than, okay, so this is so here X bar is 446 minus 448, 21 divided by root n is what? 49. Okay, this could be the Z value here, and here the Z value is 441 minus 448 divided by 21. Okay, you'll have a two set of Z values. So one is 0.67. So this is going to be 0.67 minus 0.67. And this is minus 2.33. Okay. So the normal curve would look like this. This is Z curve. Okay. So here it is. This is 446 would come before this, huh? By the way. Okay. Find out the appropriate Z values that we have discussed. So this is what a difference. So 24% chances are there. Okay. If you find out a difference, then 24.15% chances are there that the chosen sample, okay, may have a mean which can be lying between 441 to 446 shoppers. Okay, got this? Yes or no? Got this? Yes or no? Got this? Calculations? Okay, okay, Nikhil. Now the next example is So here the next example is when the population size is known to us, what we can do, I mean. So let's keep one example of that type. So यहाँ पे they have given that a production companies 350 hours, 350 hourly employees, average age is 37.6 years. Okay, in one manufacturing plant, okay, they have hired hourly employees. Okay, so their hourly employees age, average age is 37.6 years. Okay, तो ये एक प्रोडक्शन फर्म है जहां पे they have hired hourly employees जिनकी औसत उम्र है 37.6 years with a standard deviation of 8.3 years. Okay, now the random sample of 55 hourly employees is taken. Okay, what is the probability that the sample will have an average age less than 40? बड़ा ही simple question they have asked that so this is a population of their hourly employees. Okay, so the population mean is 37.6 years. Okay, now if we consider the distribution of x bars distribution, okay, then what they have said, standard deviation is 8.3 years. Okay, if a sample is chosen, there is a small sample which is being chosen. Okay, it's containing 45 employees ka data. What are the chances that this sample will fall in the sample's average age is less than 40 years, age less than 40 years. So here let's say somewhere it's a 40 years. Let's say here it is a 40 years. This is a 40 years. What are the chances that the sample average x bar of this sample would be below this line, somewhere below this line, red line? Okay, again let's apply the same formula. Here x bar should be less than 40 years. That means, but here the population is known to us. 350, population is 350, n is 350. So this way Z area should be less than x bar minus mu, okay, divided by sigma by root n to hoga hi, okay, but there will be capital N minus small n and small n minus 1. Ye formula you have to at least accept it. Okay, it is a very simple formula, but you have to accept it. Okay, there is no alternative of it. You have to accept this formula. Okay, it's very simple formula. It's a difference of two sizes, population and the sample size divided by degrees of freedom. It's very simple. Okay, so Z value is, let's say here 40 minus 37.6 divided by 8.33, right? 8.33 is there. Yes, 8.3 years. 8.3 years. Sample we have chosen of, what is the sample size? 45. Population size is what? 350 minus difference between the sample and the population is 350 minus 45 divided by degrees of freedom. If we calculate the sample, if we make some calculations based on the sample data, how many random choices we can have? So 45 minus 1, 44 choices we can have, because 45 observations would be there in a sample. So this Z value could be, so let me just plot a Z value chart again. So this is a normal chart of normal curve of Z values. Here it is a 0. At this point Z value is unknown, so let's find it out, the Z value. So that Z value is nothing but it's 2.07. if it is a 2.07, we are looking for this area because probability is x bar is less than 40. X bar can fall somewhere here. It can fall here. It can fall here, here, here. Any just below this red line, red line, anywhere x bar can fall. Okay. So by mistake, I have in the previous example, if you remember, this line supposed to be left of this mean line or let's say median line. Okay, वो याद रखिएगा कि ये लाइन जो थी लास्ट टाइम 46 वाला, तो वो एवरेज था 48 समथिंग, और वो लाइन जो मैंने यहाँ ड्रॉ की थी वो यहाँ होनी चाहिए थी. Though I corrected it later on, okay, in the Z curve, but please remember that while you are watching the video, please remember that recording. I mean, please remember that. Okay, or you just follow the book for that particular example only. Okay, so here the probability value is this. The probability value is 0.9808. So 98% chances are there. 98% chances are there that if you draw a random sample of 45 hourly employee, their age would be below 40 years. 350 hourly employees working there, but out of 350 hourly employees, if you take a sample of 45 and if you map their average age, then there are 98.8% chances हैं, 98.08% chances हैं तो उनका average 40 साल से कम आएगा. That's a simple interpretation. Hope you got this. No, denominator cannot be population n-1 नहीं आता कभी भी. That cannot be known as degrees of freedom, Aishwarya. It's sample -1. It's a sample -1. No, it is not like that. Oh, sorry. It is n-1. Sorry, Aishwarya. It's capital N-1. Population is known. Sorry. Capital N-1. Sorry for that. Thanks, Aishwarya, for the correction. It's capital N-1. Population is known to us. It's for the finite population. Yes. In the case of finite population, you can choose a capital N-1. Can be considered as a degrees of freedom in that sense. Yes. But entire thing can be done for the degrees of freedom. Everything, entire notation can be done for the degrees of freedom. Okay. Thanks, Aishwarya, for the correction. Yes. Next example. Let's say many times the population proportions are known only. Okay. Only population proportions are known in place of actual values. So how can you at least derive the things? So let's take one example of that type. So here, let's say if you observe here, so problem is if 10% population of the parts is defective, what is the probability that the randomly selecting 80 parts and the finding that the 12 or more parts are defective? Now we don't know the actual sample size. Actual population size. We don't know the actual population size. But irrespective of informing, let's say irrespective of the population size, we got the information that the 10% of the entire population is defective. What is the probability now that the 80%, let's say randomly selecting 80 parts, okay, we found that 12. What is the stake of those 12 parts out of 80? What percentage of those 12 of 80 15%. So we don't know the actual population size, but we just know one information regarding it. It's a proportion. That the 90% parts are okay, but the 10% parts are like defective in the population. Okay. Let's say 90% parts are okay, 10% parts are defective. This is a 10% defective one, 90% okay. Now we have drawn a sample. Okay, sample should look like this. This is a sample. Okay, 12 are defective. Okay, and 80 minus 12, that means 68. Okay, 68 parts are okay. Okay, these are defective. Now if you look at this proportion, this is what, 12 by 80. What is the proportion? 15%. What is this? 68 by, so here the formula is this. Here the formula is this: P cap minus P into Q by N. This is a formula of finding out the Z. Now what is the question been asked to us? I mean, we need to find out the possibility that 12 or more parts are 12 or more. Okay, proportion that 12 or more. That means probability that P could be 0.15 or more. Okay, proportion of 12 is 15, right? So out of 80, let's say 15% and more. तो उसको कहा जाता है कि out of 80, let's say 12 or more parts are defective. Now the formula is P cap minus P, okay, P into Q by N. Okay, so what is P? This is your observed, this is your sample, this is your population. The sample proportion is what? 15%, 0.15. Population is 0.10. Now what is P into Q? This is 10 population parts, I mean defective parts 10. Q stands for okay parts, 0.90 divided by N. Sample size, because population size is still not known, so sample size is known. What is the sample size? 80. Okay, so probability that Z is greater than this value. What is this value? 1.49. Okay, Z is greater than that value. So here Z is greater than this. So here Z is 0. This is a positive side of Z. So here somewhere it's like 1.49. So we are looking for the probability of this part. Okay, but we may get the probability of this area. This is known as probability Z is greater than 1.49. उसको ये भी कहा जाता है कि probability that 15% or more parts are defective. Now, if you interpret this particular area, which is 1.49 Z value, so this is known as probability that the Z is less than 1.49. So probability that proportion is less than 15%. So 15% or less parts of 80 are defective. Okay, this can be accessible through cumulative probability table. तो cumulative table से इसको हम find out करेंगे, okay, और 1 में से इसको subtract कर देंगे, then we'll get 0.0681. So this is a probability that 15% or more parts are defective. So there are 6% chances, or 6.81, roughly 7% chances that if you draw a sample of 80, then 12 or more parts are defective. So 12 का proportion is 15%. जो 12 हैं, they are 15% of 80 parts. So we can say that there are 6.81% chances that 12 or more parts out of 80 could be defective. In a way, we can say that there is a probability of 0.06 that 15% or more parts of the sample of 80 could be defective. I hope you got this. Clear up to here? Up to here, any question, anything that you would like to ask? Hope the things are okay. Anything? Is it okay? Hope you got each and every concept that we have discussed. Next time we'll start with the correlation. Meanwhile, please download the trial version of SPSS. Okay, you may use R also, but before you, okay, those who want to utilize, or let's say those who want to work on R, first you download the R's and then you download the R Studio. Okay, this is definitely not there. The softwares are not there in your syllabus, but just for your knowledge, I thought that let me just share with you. So I'll discuss the concept of regression and the correlation in the next session. But before that, you should be ready with the software also, SPSS. Okay. Those who want to, Stata also, you can at least, you have an option of download, you just keep it downloaded in your system. Stata, you can at least be ready with the Stata. And those who want to use SAS, there is a student edition or university edition, I guess, I don't remember, but yes, which is freely accessible to all. Okay, go to the website, I mean,